Okay. Hi everyone. You have people. Looks like I need to restart my Zoom client, so let me just quickly do that. Sorry for that. You may need to rejoin. Let's see what happens. I will make Praneeth as somehow Srihari not here.
Srihari actually disconnected, so I think he might be joining again. Okay, he's here.
Yeah, Srihari is connecting. Perfect. And let me just share my screen and then we'll start. Can you guys see my screen?
Yes, Dhruv.
Okay, thanks, Sherry. Thanks, Praneeth. I think people are joining in. Praneeth, would you send one reminder as well on the WhatsApp while?
Yeah, I'll do that.
Yeah, and by the time, like, let's not waste time. So I'll start with the initial introductions, for instance. So welcome to RFCs We Love. Today's main topic is the hot topics in the routing area that have been discussed in the past IETF meeting, and that I wanted the bigger community here to be aware of what's happening in the IETF, especially on the routing area side. This is our 25th meetup. So we have been doing RFCs We Love for a while. And though we wanted this to be in person, but we ended up doing this virtual itself. But if people have venue suggestions and want to host us, we are open. So if your office is allowing these kind of conferences and we want to meet in the weekend, we would actually love to have a physical RFCs We Love. So do reach out to us if that's a possibility and you would like to take a lead in organizing one. So we're looking forward to more participation in this side. This event is organized by IISOC. We do multiple other things, like for instance, at April of this year, we did a connections event, which was a 5-day event with INTC, which went quite well. We do IPv6 webinars series. The latest one was the extension header. And in fact, 2 days back, we did one on AWS, which was quite interesting. It was a very good presentation on how AWS uses IPv6 in their VPCs and what are the set of features that they provide. So like this, you will find a lot of good content in webinars format and in events that we do. So we're looking forward to more suggestions and participation from folks. Now, a note, IETF 115 is coming. It's 5 to 11 November. It's happening in London, plus it will be online. The online part, you can apply for a fee waiver. So please use that opportunity and participation. We want to continue to see a lot more participation from India, and that's one of the main aim of IISOC, and that's why we are organizing all these events. So we want to make sure that more and more people come and participate in the ITF meeting. I think I'm going to skip the poll. Looking at the participant list, here it is. I sort of know what's happening. So let's skip on this and focus mainly on this activity. So IISOC is a membership organization. So you can easily become member. Membership is completely free. The benefit of membership would include things like you would be able to help set the agenda for IISOC. We have, in fact, a voting coming up for the vote seat. So where we will be sending out an email to you with the set of nominees, and we will be requesting you to vote, and also have open membership meetings in future where you could provide us with feedback on what's working, what's not working, how IISOC needs to change. So we are hoping to have much more active engagement from the member community. So please become members. We have a mailing list, we have a direct email, there is a Twitter, there is a WhatsApp, which is the most active form for us to communicate. I will post the links of all of this once I've stopped presenting. So you should have all of this with you. Looking forward for more engagement from everyone. And at least a general request to please become member if you are attending any of our events. So ground rules. We will be using Zoom webinar Q&A option. So if you have a question to ask speakers, please use Q&A. If you would like to generally chat and have informal discussions, then use the chat feature, give feedback via chat, talk is free. But if you have specific questions for our speaker, it's easier for us to track by looking at the Q&A section. So please use the Q&A feature as well. As well as you can always raise your hand and I can give you permission to for audio, and you can even speak your question. But I think for record keeping and general discussion, our preference would be written Q&A. But if for back and forth, we can always enable audio, and you could have more further in-depth discussions with the speakers that we have today. So let's start. You might notice there is a small change. We earlier had Shraddha, who was supposed to present on our first topic, but she had to leave Bangalore. And we are so thankful for Srihari to step up and present on her behalf. And Srihari and Shraddha have anyway been working on this very, very closely. So we are looking forward to this very good interaction on intent-aware inter-domain routing. The second topic for today would be by Pawan on Mpls network action. This is the change in the Mpls header that has been proposed. And this is also would have a huge impact on a lot of our networking and routing area. So both the topics are really hotly debated currently in ITF. So if this interests you, this is a very good time to come and participate in ITF on these topics as well. And that's why we wanted to bring these two topics to you today. So let's move on to the first topic. Our first topic is intent-aware inter-domain routing. There have been a lot of changes in our network, like especially with 5G coming in, there is idea of having differentiated services. We would want just the best path from IGP, and BGP doesn't work. We need to have a lot more intent, which is minimum delay path, which is more bandwidth intensive path. So we would like to have various different intent in paths, which we were anyway doing within a single domain, but how to achieve this in a scalable fashion in an inter-domain using BGP and using a concept of color. That's the that will be the main topic for today. So I will not go in detail. We already have Srihari here, who will go and explain what this is all about and various different solutions that are being currently proposed in the IDEA working group and being discussed there. So Srihari is a distinguished engineer at Juniper. He has a lot of experience. He has been in various different product companies. He has been active in ITF for a while, and he has presented in our past events as well. So you most likely know Srihari quite well. And thank you, Srihari, for being here and talking about this on this Saturday, giving us your time. I'll stop sharing and you can go ahead and share, and let's start the first topic.
Sure. Thank you, Dhruv, so much. Let me try and bring in the slides and I will start sharing. Okay. Can you guys see what I'm sharing?
Yes, Sherry. Maybe make it full screen.
Yes. Is it better?
Yes, go ahead.
Okay. All right. All right. Thank you so much, Dhruv, for introduction as well as setting the agenda for this. This is a great event. This is my second speaking session, the ISOC. It's a great forum, and thanks to Dhruv and the key participants there to drive this for so many number of years. So this is really great forum. And welcome, folks. What I'm going to talk about today is the intent-aware routing. This is something that's is going on at various groups in IETF for more than 2 years with this thought. There you can see a lot of discussions on IDR, and there have been some discussions on Spring, and may have been some discussions on the BESS. So what I'm going to talk about is give you guys a very high level idea of what is the problem statement, what are the various use cases, and what sort of solutions are out there. And I'll briefly touch upon the solutions towards the very end. And like you see on the slide here, Shraddha has been the primary person driving from Juniper, and Dhananjay Rao has been the person from Cisco Systems, and you can see a lot of names in the second section where a lot of customers have shown interest, have provided specific comments, feedback, and exposed their use cases into this, so which we have captured in this document. Okay. And like I said, I'm going to touch upon what problem are we talking about and what is the need for the BGP-based solution, what is driving the BGP-based solution here. And you will also see there is an interesting set of 2 documents that got emerged at IETF, one from primarily from Juniper and one primarily from Cisco. And based on what the chair's recommendation, we had to merge the sections. And I'm going to talk about a little bit more on how that went on and where we stand on this. All right, let's talk about the problem statement. What are we talking about here? You know, Dhruv touched upon this at the very beginning. We have been aware of this intent aware within the domain for a while, and this intent can mean I've been setting up a low-cost path from IGP metric perspective from one end of the network to the other end, and it could be bandwidth or it could be latency. Now, the moment we talk about multiple domains, we now need to really see how we can establish through the same intent-based path from one end of the network across multiple domains. And these domains could mean IGP domains, or it could be ASS, but still considered well within one administration domain, right? So this is all about establishing my intent, which I will define, which could be latency or delay or bandwidth, and that intent should be maintained throughout across multiple domains. That's the end-to-end intent-aware paths to be established. Now, we may also know that some of these problems may have been solved through centralized solution. There will be many solutions out there which feed all the information to one centralized entity, which will then compute the path and then distribute it across the various network points. But this solution is distinguished such that it is a distributed routing solution. So we are now talking about that the information needs to be spread across multiple nodes in the network, and they will compute, and there is no centralized entity that is needed to compute this end-to-end path. So it is truly a distributed routing solution. And we all know the distributed routing solution that scales well in the internet today is BGP. So this solution is based on BGP. And some of the requirements, as I talk about through this in this presentation, as well as captured in the various documents, is applicable for many other solutions. The moment we talk about distributed routing solution, one can say that BGP may not be the best fit. Maybe we can think about something else, a solution that can be, existing solutions can be enhanced to solve the same distributed routing solution. So though this solutions talk about BGP specific, but it doesn't necessarily limit to only BGP, but the solution space has to be on the distributed solution. So we're not talking about centralized, we are still talking about distributed, but can be expanded to other protocols beyond BGP. Okay. All right, so some of the driving factors here, clearly 5G stands out to be the tallest pole there. We all know there's a massive bandwidth growth, and the timing and the end-to-end latency is one of the key for the 5G applications. Given that there'll be a huge number of nodes, operational simplicity is going to be very important, and you can see a lot of applications driving this 5G. Clearly, high availability is going to be a very important one. And of course, when we talk about simplicity, some customers, or many customers, I should say, talk about how do I minimize my protocols on the network. That will definitely reduce a lot of operational complexity, maybe states and things like that I need to worry about. But at the end, we are now talking about we have to have end-to-end same sort of a service provided from one end of the network to other end of the network, because these applications, it could be EMBB or URLLC, or any of those applications can be driving the specific service requirements. So that differentiated services is going to be the key. And that means we're now going to have the routing sort of have application awareness that needs to be brought in, so that we will be able to provide that SLA throughout the network on each and every node along the network. Okay. So given this sort of a problem statement, like I said in the beginning, there have been progress and efforts from multiple companies. One primarily from Juniper that Shraddha and team drove, which they called it as Seamless SR. And there's a document, there's a draft that's out there for more than 2 years, which captures all the requirements, deployment use cases, and Shraddha has presented in multiple work group meetings in the past. And this is the first document that is mentioned out there. The second document is primarily from Cisco, and that's a document out there, and you can take a look at it. And that also captures similar requirements from the various customers. It seems both Juniper document as well as Cisco document have a very common customers, and both the customers have provided feedback for these. So when Cisco and primarily Dhananjay presented in the workgroup meetings, there was a recommendation from the Spring workgroup chairs to see how they can, how the two companies of the two vendors can get together and come up with a merge document. And that is exactly what came out in the third document, which is mentioned at the bottom, which is the intent-aware routing. And there is a huge amount of work that has gone in. People like Jim Utaro has been a primary member in making sure that the two vendors get together and work through, and Joel Harpon has been also a primary member in making sure that the two the two problem statements get merged appropriately. So kudos to the various people working together. We now have a merge document that was presented in the last IETF. And we still have some more work to do, and I'm going to capture some of the progress there in the later part of the slides. All right, now what is the need for this sort of a solution? Hope you guys can see the Dhruv. This is not blocking people, right? The tab at the top.
No, I can see your arrow, so your pointer is visible.
Okay, all right. So let me also shrink this. This is oh, sorry. All right. All right. So from a need for what is the need for distributed BGP solution, right? Now we all know operational simplicity is going to be the key because of a lot of deployments out there. The networks are growing in a big way, right? And in such a network, you definitely need to have something that customers are more familiar with. And we all know BGP is sort of ubiquitous, and then there are a lot of operational experience and expertise have built in on BGP across multiple customers' networks, right? And we know BGP brings in a lot of higher scale. When we talk about higher scale aspects, and BGP comes to the mind for everybody there. Right? So BGP has been the key protocol for extending and to solve this intent-aware end-to-end path. And at the same time, we know that Mpls architecture is again fairly well deployed across various customers, and customers are familiar with the deployment aspects of Mpls and how to manage the network. Right now, when we talk about multiple domains, BGP comes to the mind because BGP clearly provides a lot of policy constructs that customers can use for establishing the trust and enabling and describing those the policies. I mean, through those trust specifications through the policies. So clearly these things point to BGP and how do we extend BGP there for making this end-to-end aware path. And in the next set of slides, I'm going to just talk about what sort of topologies that that comes to my mind. Now, clearly the number of nodes are increasing in terms of various networks. Networks are growing bigger, and 5G is going to definitely push in the same direction. So we are now talking about nodes in the order of hundreds of thousands of routers. And because the networks are growing, people have created smaller domains, which means in one big network, you could have multiple domains. And each domain will have some set of routers, and you need to have connectivity, and establishing of end-to-end path across these multiple domains. The key thing that one will notice is it is still one big administrative domain. So you can say one administrative domain, OAD, can be the big thing that you can think about, but it doesn't necessarily limit only to those. It could very well be across multiple administrative domains as well. And when we establish any path, we are now talking about the service level agreement or service level objectives to be established, and that needs to be catered and adhered throughout the end-to-end network. And it could also mean that we will have low latency routing, not necessarily only the specific existing method of doing things, but these are all the things that are going to be driven by, let's say, EMBB or URLLC kind of services. In other scenarios, we're now talking about it could be smaller IGP domains because we now want to reduce the overall state on the device. And it also means smaller fault isolation and fault domains there. And the key thing that we are hearing from various customers is data sovereignty. And I'm going to have one or two slides later on to talk about specific. And given the various politics in the world that's shaping up, there is a lot of trust issue that I don't want my traffic to be crossing over specific domains, countries, geographies, and we want to be able to control that. So data sovereignty has been a primary reason that many customers wanting to have this end-to-end path established. In another scenario where you can see the data center interconnect, you definitely want to have the end-to-end path diversity. I want to be able to take the leverage of multiple different types of paths that I have. And I want to be able to have a specific set of paths. Let's say low latency could be the primary thing there, and low latency path. I want to be able to establish a low latency path. And certain service routes need to be avoided because these are all, you don't want to have loading a specific set of routers with lots of routes. So, sorry. So how do I keep my routers fairly less state in each of these routers? Sorry about that. Talking about data sovereignty, you could see in this picture, there are 3 different ASs and a bunch of connectivity across various routers. Let's assume it's all single, there are multiple ASs here, and each AS represents a continent. Now, sitting in AS1, and traffic is being sent from P1 to P2. And I want to be able to say, I want to avoid specific nodes in a remote autonomous system. Okay, so in this example, I want to be able to avoid node A and node C in the AS3. Now, this avoiding A and C is not a constraint in other ASs, which means it is only applicable to the AS3. But AS1 and AS2 should be able to route fairly as per today, as per existing mechanisms. But the constraint is only applicable in AS3. Now, how do we do this? Let's say we establish a path, and you could see the red LSP is the one that avoids the A and C and still gets to P2. Now, this is the thing that we want. But in order to achieve this, we want to be able to establish some constraints only in AS3. Let's say in AS3, I will say when we resolve the paths, there should be strict resolution where I want to avoid the nodes A and C. But that strict resolution need not be applicable in AS1 and AS2, which means in AS1 and AS2, I can say I can fall back into any other paths, could be best path, best effort paths or anything like that. But I do not want to fall back to best effort in AS3 because that may take me through A or C. So on AS3, I want to have a very clear, specific, strict path resolution, but I could relax that on AS1 and AS2. Okay. All right. So the next couple of slides just show you guys on how we went about on the merge document. You could see a lot of sections in here in the merge document are fairly common between the two documents. These are all pretty much common. All of these sections were present both in the seamless SR document as well as in the color-aware routing problem statement document driven by Juniper and Cisco respectively. What you see in the underlined ones are things that we need to still work more. This is not a finished document. What we've pushed out is the 0.0 version or an early version of it. And we may have to, we will have to add more text into these sections, specifically the VPN network intent, as well as multicast and OIM. And we plan to complete it in the next before the next IETF. We want to publish this, but the document is fairly complete in terms of the base use cases and the motivation. I would encourage everybody to go through the merge document and provide comments as you feel. Now, the next set of slides talk about or at least capture some of the transport and various requirements as we see in the merge document. So minimization of end-to-end metric. Clearly, when we talk about interdomain and when we establish an intent, if my intent is minimizing the end-to-end metric, and now I want to be able to have this intent maintained across multiple domains, and let's say this is about cost, and I want to minimize the end-to-end metric. Or it could be that I want to include or exclude certain link affinities. It could be certain links that I want to completely avoid because it goes through certain routers, or maybe they don't cater to my SLA. So I want to include or exclude those links, and they will be sort of colored with that sort of link affinity. And likewise, it could also mean I want to include or exclude certain nodes. And certain cases, in specifically the data center, I want to have able to have the diverse paths. So diverse path diversity is also one of the key things. And we also talked about in the past that in the few slides before that, I want to be able to apply a specific intent only a subset of domains, not all domains. I want to be able to have that control. Maybe I want to completely exclude a domain or include a domain. And certain network functions, maybe I want to be able to place certain network functions on certain local domains or core domains, and I want to be able to have the flexibility on that VNFs. From a steering perspective, we want to be able to have all the flexibilities here based on customer requirements. Per destination steering is one. Maybe per flow steering is also second one that we want to have. When we talk about fallback, this is fallback primarily is driven from this factor. Let's say I will establish an intent to go through, let's say maximum bandwidth. And if certain links are not available, certain paths are not available, then what is my fallback option? And fallback option can be ordered, which means that I want to be able to fall back into second in the tier 2 and tier 3 kind of paths. So it's an ordered fallback is one. Or maybe I want to just fall back into best effort. In certain cases, I do not want to do fallback on best effort. In certain cases, I want to, maybe I can fall back into best effort. So the customer want to be able to have that flexibility. In certain other cases, customers do not want to have fallback. We want to be able to support that. In certain other cases, customers have said, I want to be able to have that fallback scheme per service route. So I want to have the granularity. In certain cases where both the service routes, there are two service routes, each service route have a different fallback, but their primary is still the same. So service route 1 and service route 2 have the same primary path, but when the primary path goes down, service route 1 wants to have a fallback to fallback 1, and service route 2 wants to have fallback to fallback 2. Right, so two different fallbacks for the same service route for the two service routes, but for the same primary. This has been one of the feedback that we got from customers. And like we know, we have many different services, L3, L2, IE, VPN, all the services need to be able to support on this end-to-end path establishments. Okay. Scalability, this has been the key factor, given the number of nodes are increasing, domains are increasing, and the span of the domains are also increasing. And we, based on the customer requirements, we have said the nodes can grow beyond 300,000 routes. So any architecture, any solution should be able to solve problems for this over 300,000 nodes. And the colors, and when it's a color is sort of a thing that's almost in many different documents and work groups. We talk about intent and color sort of inter-exchange, the sort of exchangeable sort of terminology. So colors, we're not talking about more than 5 different intents expressed as colors can be something that we want to be able to support. So anything beyond 5. Mpls data plane solution is now we need to be able to help scale that, to be able to support this. And from a control plane perspective, sorry, maybe RTC kind of mechanism. So something pull model will be something that we want to be able to have that for scalability. And also automate the subscription and filter mechanism. And at the same time, whenever we go down with this mode, we want to be able to have that efficient propagation and processing of those subscription filter routes. So we do not want to overload any one router to have huge load, because when we push the load into foreign devices we know are going to be fairly low end, given that 5G is going to push for a lot of deployments in towards the last mile. So those devices are going to be very small in sort of form factor and the CPU. So efficient propagation is going to be very key there. Okay. Now on the solutions part, there are two solutions, BGP CT or classical transport, primarily driven by Juniper. Kaliraj and a few people have been the primary authors of that. It's been out there for almost more than, I would say, 1.5 to 2 years. You can definitely take a look at the draft. It has a lot of customers providing feedback, a lot of support from various different customers on that, with other vendors as well. And this has been presented in IDR for a while now. So this is BGP CT. BGP color aware routing. This has been primarily driven by Cisco. And again, even here, there are a lot of customers supporting and many different vendors supporting them. And they have presented Dhananjaya being the primary co-author, and few other co-authors from Cisco and other vendors. They have presented in a couple IDR sessions. You can take a look at the documents out there. Now, at this stage, I'll just touch upon what these solutions bring and what are the key differences between them at a very highly level. And you can look at the documents, also listen to the various presentations at the IETF for more details. On the classful transport, this primarily leverages the existing L3 VPN or VPN mechanism and extends that. In VPN, we know it's going to be an RD, the route distinguisher, which is provides the unique differentiating factor across multiple nodes. And you have the route target extended community that provides the membership information so that you can come up with a closed user group and provide the VPN connectivity. So you have a RD and you have a route target RT. This is the existing VPN mechanism. BGP-CT leverages this VPN mechanism and extends this. So they come up with a new SAFI with encoding the BGP-CT route, and color is communicated in a special route target called classful transport community, where you embed the color, and when you send a route, you're going to say this is the BGP-CT route with this is the color, and the color is the emanating router. The originating router says I am going to provide the connectivity for this intent, and the neighboring routers advertise just like the BGP LU, where you have the LU route with a label. In a similar fashion, BGP-CT route with the color intent carried in the route target in the special CT route target with the label gets propagated from the ASBR or ABR into the other end of the network. So it follows exactly the BGP LU mechanism. So the ingress router on the far end of the left receives a BGP-CT route, which says I'm gonna have this label that I can use to reach that particular endpoint, and that endpoint provides me this intent because this is the color that is carried in the classful transport route target. Right now, it follows the BGP LU mechanism, and every domain you can map the intent into the intra-domain path. It could be RSVP path, it could be SR path. It doesn't matter. So you can map to any of the SR or the RSVP paths in each of the domains. This is how the CT works. Right, so the path diversity is maintained in each of the intra-domain, and end-to-end path is maintained because you are able to map the color. Now, let me touch about car, and then I'll bring about the differences between the two. On the car side, the mechanism is the NLRI encoding is such that you are embedding the color in the NLRI itself. So their solution is I'm going to come up with, I'm going to have a new NLRI format which says this is the endpoint, which is, let's say, the IPv4 address, or it could be IPv6 address. That is the endpoint, but the endpoint is distinguished with a color. So the endpoint is truly a color : prefix, and the color is embedded in the NLRI. Now, because of this, the new NLRI format has been proposed, and in the NLRI, you not only have color, which is the part of the key, you also have sort of non-keys. Like we know in the VPN MP reach format, NLRI format, we have a label that is not part of the key, but that is part of the non-key. They use that mechanism to also include prefixed and some of the SR aspects into that. So the NLRI format now has a key, which is the color : prefix, and the non-key, which are the labels and the SIDs and the SID related information there. Okay, so that is your NLRI. So when the border router advertises, it advertises the NLRI, which is the color : prefix, and the forwarding information in the non-key, and that gets propagated similar to the BGP LU to reaches, and that reaches the endpoint. the other endpoint. Okay. Even in here, they can map to any of the intra domain paths, could be RSVP, could be SR paths. And you are able to provide using CT or using CAR, you are able to establish the end-to-end paths. The key differences between the two are this. If you see, CT uses VPN mechanism, they employ RD and classical transport route target. Whereas CAR, they do not have RD. They can use RD only for the VPN extensions, but if it is not VPN, they do not need route distinguisher. Instead, they have color in the NLRI itself. And one of the other differences between the two is when the domains, let's say you have a domain 1, domain 2, and domain 3. And in the simplistic case where the intent, let's say intent is red color, if the intent is low latency and the color is red, representing the low latency, is the same across domain 1, domain 2, and domain 3, it is fairly simple. You don't need to do much about it. In the CT, you have the red color embedded in the in the classical transport route target that is sent from one end to the other end of the network. Things are good. And in the CAR, the color red is embedded in the NLRI and it is sent from domain 3 to domain 1. Things are good. This is fairly simple. But in the other case where, let's say the domain 2, the middle domain, has the low latency mapped to green color, in which case the domain 3, when it sends a red color NLRI in the CT, on the domain 2, they will have to map the red color into the green color. You have to look at the original intent is expressed is red, but then I have to map into the green color because I use low latency as green, and therefore it's a mapped community that is sent in the domain 2. Eventually again gets mapped in the red color onto the domain 1. In the CAR, because color is embedded in the NLRI, when it reaches the domain 2, it can't change the color because now you're going to be changing the NLRI itself. Therefore, they come up with a new community called LCM. And that's where the local color is maintained there. So the green color is carried in the LCM community, whereas the red color is still in the NLRI. So and when it comes back to the red in the domain 1, it again the red color is maintained. So sort of when across domains, when the colors are different, that is where the CT and CAR behaves differently. And then how intent is maintained from one end of the network to the other end of the network, and how the fallback is used. Those are the three differences that are there between the CT and the CAR. And at this point of time, we have had a lot of discussions on IDR. If you go back on IDR mailing list in the archives, you can see some customers supporting CT, some customers supporting CAR only, and some customers supporting both CT and CAR. So at the current stage, where in the IDR, we now have accepted the co-chairs have accepted both have experimental, both CT and CAR are experimental drafts, and we're going to see how both will evolve. There is also a document which talks about the interoperability between the two, how a CT prefix can be translated into a CAR, and vice versa, how a CAR prefix can be translated into CT. Now, what we will have to see is how customers will experience the CT deployments and CAR deployments, and how do they see evolution of both. Maybe both will be evolved and both will be deployed with interoperability, or maybe they are going to look at something that's a more preference for them. So that's to be seen going forward. But at the moment, both have been, both are available. CT solution has been available in Juniper releases for more than 1.5 years now, and I believe CAR is also available in certain other vendors along with Cisco. So now. I would suggest, I would encourage everybody to go look at CT and CAR solutions and see how customers, prefer solutions and how the deployments will go through. So that'll be interesting thing to see the intent-aware routing side. And this is my last slide. I'll pause here for any questions. How am I doing on time, Dhruv?
Srihari, very good. No issues there. We have a bunch of questions. Let me just take it up one after the other. The first question is a good one. It says that why is the problem statement being discussed in Spring, whereas the solutions are in the IDR? Basically, when you also mentioned that we could also use RSVP based stuff. So anything that you can answer with respect to that?
Sure. The origin goes about like this. When the seamless SR problem statement was described, was drafted by Shraddha and team, because this was SR and it sort of helped to propose this in Spring. So Shraddha presented this in Spring, and sort of this became a Spring problem statement document. Whereas when the car problem statement document was proposed, they proposed it in BES, because this is VPN services, something that we want to provide the intent-aware paths for VPN services. But then across the IETF co-chairs, they all discussed, and they requested the car authors to present this in Spring. So this became a Spring problem statement document, whereas because it was both were talking about BGP, the solution were discussed, both the solutions were discussed in the IDR. So at the current moment, because this is a SR driven document, so the Spring chairs have accepted that this will be a problem statement document in Spring only, and they will feed this problem statement requirements into IDR, and the solutions will be discussed in IDR, because it's all talking about the BGP extensions. So there's a bit of history here, but at the moment, Joel Harpen is clear that he's going to have the problem statement position at Spring, and the solutions, Suhairs is driving the solution, and that solution will be described in IDR.
Yeah, thanks, Srihari. There's one question from Ramkrishnan, but before I give Ramkrishnan ability to talk, I just wanted to give a indication that earlier our plan was to only cover requirements, and only in the later time I've asked Srihari to also go over the solutions, because that's where the interesting part is. And there were some comments with respect to, like, if there is a topology, it might have been easier to understand. So it's our fault, like, I gave that requirement to Srihari only at the last moment. So that's why you don't have, but a lot of good material is available on the past IETF meeting. So if you go to IDR meetings, material, you will find good diagrams that explains the flow of packet for both the car and CT. And let me just also allow Ramkrishnan to talk. Is there anything more specific you would like to ask Ramkrishnan? You should be able to speak now.
Thanks to Yeri for this wonderful explanation on this new draft. So I was trying to understand that what are the what are the solutions it will be fitting into the service provider network. For example, we have connecting to when two SPs are interconnecting, right? Now currently Indosat and Hutch is merging, or there could be any kind of other pairings will happen. So where are these solutions will really fit in? So that was my keen interest to know that, Srihari. And
Sure. Yeah, thanks, Ramkrishnan. This is a good question. The scenarios that primarily will be driven from this. Today, we will connect multiple domains. You could do Flexalgo leaking. That seems to be the simplest one. Or the other one could be people have been using BGP-LU for providing the interconnectivity between multiple domains. So this is done today. Now, if the new thing that is coming up is for the various use cases that we talked about, I want to be able to establish a specific intent, and I will have two different paths. One providing, let's say, bandwidth, high bandwidth, and other one providing, let's say, low latency. Just take the two simple examples of the EMBB and URLNC, right? Now, it is not just sufficient that I provide this only in the core network. Let's say in the typical scenario, we have a metro core and then the metro. We know some customers some customers have a very diverse set of paths only in the core, and metro are fairly simple, because metro you'll probably be having a ring and then either go left or go right. So fairly limited in terms of what flexibilities you have. But in certain other customers want to be able to also have more flexibility in the metro as well, metro regions as well, what they call the pre-AG and the AG, right? So in such a network, either you have your own single autonomous system where you have carved out multiple domains, multiple different IGP domains like that, or you could have two different domains two different networks coming and merging together, like Vodafone India or in such customers where they are merging the two networks, and they have their own different versions of how diversity paths are established. Like everybody will be aware of, these paths give me maximum bandwidth, and these paths are delay sensitive, and therefore they provide low delay, low latency paths, right? So when you merge the two networks, or when you have such multiple domains, sitting in one end of the network with this far end of your domain, and from leftmost metro going to the rightmost metro through across the various core, and each of the domains as you go through, you have multiple choices of how many maximum bandwidth sensitive paths and delay sensitive paths you have in each of the domains, and how do I map, right? That is the problem statement, and each such interconnecting paths, the interdomain routers that you provide, right? And how do I connect those multiple paths so that you still have end-to-end single path establishment, but running this with a distributed method, right? You could always come up with a centralized at the top. You feed all the paths to the centralized guy, and centralized guy will figure out and then push down the paths. That's not what we're talking about. I want to be able to have some signaling coming through from each of the routers. They will advertise their specific intent-aware paths, and at the far end, you get multiple intent-aware paths, and I want to be able to resolve those intent-aware destinations, the remote endpoints, mapping to my local paths, could be RSPP paths, could be Mpls paths, or anything like that, and still be able to maintain the same end-to-end SLA. So that is the requirement, and that's how the solutions came up in providing that. Hope I answered the question.
Yeah, thanks. Let me ask on Muthu's questions first, which is kind of more straightforward. It says that if we have the same color to intent mapping in all domain, do we still need this solution? Which is true, but maybe you can just add a little bit more.
Yes, you still need the solution because just look at it. Let's say there are multiple. Let's say you have two colors, red color and green color, and there are multiple red colors and multiple green colors. Your statement is, I have the same intent to color mapping in each of the domains. That is true. Red is high bandwidth, and green is low delay. Let's say you've got multiple paths providing the bandwidth, and multiple paths providing low latency. Right. So you still need ability to at any one point of the network, you want to be able to say how many multiple red color paths I have, how many multiple green color paths that I have. And at the point of two domains interconnecting, you want to be able to say, okay, I'm following the green paths, I'm following the red path, and now I want to map to the red path only, right? And red path is provided by RSVP, let's say, and green path is provided by, let's say, SR path, let's say, right? So you still need that the ability to signal. The signaling extensions are needed, and how am I resolving my remote next hop to my local path? How am I resolving that? And the third thing is, let us say red path, the path that you've chosen goes down for some link failure or something like that. And what am I falling back on? Right? That is also needs to be specified. Should I fall back on red only? Or should I fall back on blue or any other path? Or should I fall back on best effort, right? That thing, or should I not fall back at all, right? So those things also need to be mentioned, right? So all these things are needed, and therefore the solutions and the BGP protocol extensions are needed.
Muthu, I have allowed you permission to talk since you had a follow-on question. Maybe you can ask directly.
Yeah, just to clarify, I just wanted to understand whether we need anything in addition to BGP color in this community if all domains are using the same color to intent.
If everybody using the same color to intent, you're talking about LCM, the car solution, right?
No, because not the car. Yeah, not the car solution. We have the BGP color extended community, right? So if I'm able to map the color in the BGP color AC to my to the one of the locally available paths in every domain, do we still need either car or CT?
Yes, I'll tell you. That. One of the things that I sort of should have been specified, should have been talked very clearly is this BGP. I mentioned this like a BGP LU. BGP LU provides you the transport connectivity today, right? On top of the transport, that's like sort of fixing your underlay, right? On top of the BGP LU comes your service route, right? So think about it this way. You have BGP LU today. I'm not even talking about color specifics here. Just talk about BGP LU. BGP LU gives you connectivity for reaching your remote peering router. On top of the peering, on top of this connectivity comes in your service route, and service route has your extended community, which says color community, right? That's today. That's not changed at all, right? And that, in fact, that technology and that mechanism is still leveraged in this intent aware. What this intent awareness comes in is, how do I establish my transport connectivity, which has multiple different colors of the transport itself, right? So you have two red transport paths to reach the same router and two green paths to reach the same router. On top of that comes your service route, which says service route will say, I want to now go only on red. So red color is mentioned in the extended community of the service route, but the transport route that I'm talking about has the class full transport extended community that has the color red. Right. So in this most simplistic case where the service route has the color red and the transport route, the CT route has the color red in the transport, in the classical transport CT route target community, right? So both are red. In case of car, the service route has the color red, and the color red, which is expressed in some numeric fashion, is present in the key of the car route. Right. So effectively, you are tying the extended community that the service route expresses to the transport route that you have either provided by CT route, which is specified in the CT route target, or by car route, which is specified in the car NLRI, which has the color embedded in the NLRI. So so you're talking two separate things. Hope I answered your question.
Yeah, thanks, really. I think I understood. So you're saying the BGP color AC is represents the color of the service route, right? And the CT and the car is for the transport. But we also have SR policy, right? Which is for the transport. So if I have SR policy and then BGP color AC, and then use the same color to intent mapping in all domains, do we still need this?
Yes. So SR policy is possibly done through some centralized entity, right?
Yeah.
Now this is distributed solution. That's the thing.
Okay.
So in the document, we also talk about the preferences. Let's say I mean, all of the solutions can be ships in the night. So you could have a BGP CT or a car route. You could also have a SRTE path, SRTE route also. And you can have, customers can say, I want to prefer CT route over SRTE path, for example, because CT is distributed, so it has a better knowledge. And for some reason that doesn't work, then you could fall back into SRTE, which is your centralized solution, and then goes on that.
Okay, got it. Yeah, thanks.
Thanks. I think there is still one hand. Rushikesh, I'm sorry. Can you just put your question in the chat and maybe Srihari can answer on the chat? But since we are running late, let's move on.
Thank you so much.
Thank you. Thank you. That was an excellent description. Thanks for stepping up at the last moment. And I am having difficulty finding where is my slide. Somehow my slide window is gone. Oh, did I close it? Okay, anyway, I think I can manage without slides. That's not needed. So next presentation, we have Pawan, who will be talking about MPLS network action. MPLS header have been stable for a very, very long time, and they are quite simple. They have been not much change as far as the data plane is concerned, but now there are new proposals and new things that are being added into an MPLS header. So this will be a very interesting talk, and looking forward to Pawan explaining what's happening in the MPLS OpenDT and various things there. So off to you, Pawan. Go ahead and share your screen.
Okay. Give me a second.
Yeah, sure.
Can you see the screen?
Yes, Pavan, I can see your screen.
Okay. I don't. Give me 1 second. I just see the RFCsWeLove logo. Okay. What?
I'm seeing an MPLS network action M&A. I think you're slide number 2.
Okay. Okay, let's go. Yeah, my name is Pavan Biram. I'm a distinguished engineer at Juniper Networks. I'm part of Juniper's routing protocols development team, where I'm responsible for driving innovations in the traffic engineering space. For the past 7 years, I've been serving as the co-chair of the TEAS working group in IETF's routing area. The TEAS working group is responsible for defining traffic engineering architecture and signaling standards. Today's topic, however, is about some work that's being done in the MPLS working group, which is um, another working group in the routing area of the IETF. The topic that I've been asked to talk about today is MPLS network action, or M&A in short. The open design team activity that produced the documents that I would be covering today is hosted by the MPLS working group, but it's actually a joint activity between 3 working groups, MPLS, PALS, and DetNet. The open design team has been conducting weekly design meetings since April of last year, and has been instrumental in producing 3 documents so far, one for use cases, one for requirements, and one for framework. And I would be covering all 3 documents in this session. I am not an author or contributor on any of these 3 documents, but I have attended a sufficient number of these design team meetings, and I've followed this work closely enough to sort of give you folks an overview of these drafts, and hopefully this would pique your interest to investigate this topic further on your own. There are multiple solution documents that have been discussed in this space, including one which is draft compiler that I'm part of. I'll not get into solution space too much, but will provide enough pointers for you to go through them in leisure and make an informed opinion on the options available and track them as they evolve. In terms of the narrative for today's session, I'll provide you some background and introduce you to what M&A is trying to achieve, and also introduce you to some M&A specific terminology. I will then walk you through some use cases which have been instrumental in getting this work charted. I'll walk you through the requirements that have been put forth, and then highlight some key components in the framework, and then we'll wrap things up with some pointers to the solutions that are being put together to realize this. Let's start by understanding the motivation behind this effort first. Um, as you all know, the MPLS architecture has been a standard for more than 2 decades now, and it's widely deployed. The base architecture gives you a mechanism for forwarding packets through the network without the need for the transit nodes to do any sort of inspection on the packet payloads network layer header. The ingress basically assigns the packet to a FEC, or forwarding equivalence class, and the MPLS label switching based architecture just takes care of the forwarding and traffic engineering of flows associated with that FEC. The base architecture did, however, have the foresight, if you want to call it, to include the notion of special purpose labels to indicate special forwarding actions. But there is room only for 16 special purpose labels. There is now a way to extend the space using what we call extended special purpose labels, but these special labels still continue to be a premium commodity, and we just cannot afford to keep assigning one for each new application. A number of applications have emerged since the inception of the Mpls architecture, which require the immediate nodes to make forwarding and also other processing decisions based on inspection of the network layer header. In some cases, these applications rely on some associated ancillary information or metadata in the protocol stack that's encapsulated in the packet. There are a couple of early examples of this. One is load balancing over ECMP or lag next stops using what we call entropy label indicator. That's a special purpose label. The other notable example is OAM using special purpose labels such as the router alert label or the generic associated channel label, or GAL as we call it. These are again special purpose labels. There are also several newer use cases which I'll get into in a few minutes that not only require the actions to be encoded in the packet, but also the associated data for these actions. What has also changed in the past 2 decades or so is that the capabilities and scale of forwarding engines has improved vastly. So there's a pressing need to match the needs with the capabilities to deliver the so-called next generation of MPLS architecture, and that's where M&A comes in. M&A or MPLS network actions quite simply refers to the set of technologies used to indicate network actions for MPLS packets and to transfer data needed for these actions. One way to look at it is that the objective behind this activity is to define extensions to the MPLS data plane architecture so that it can be used to cater to all these new applications. Before we go over these documents that the design team has come up with, let's try and understand a few terms that are used extensively in these documents and also in this slide deck. These are the terms that are currently in vogue in these documents, but it is to be noted that there's no guarantee that the terms would remain the same as they go through the working group process. So you would want to keep tabs on that. First up is network action. This is quite simply an operation that is performed on the packet as it makes its way through the network. Network action indicator, or NAI in short, is the marking in the packets that indicates a certain network action is performed. Ancillary data is the metadata that's associated with the network action. This could be data that is used as an input for the action, or it could well be the output of the action. In-stack data refers to the ancillary data that is carried within the MPLS label stack. Post-stack data refers to the ancillary data that is carried in the packet somewhere between the bottom of the MPLS label stack and the first octet of the user payload. Scope, as referred to in these documents, is the set of nodes that should perform a given action. Then we have network action substack, or NAS. This refers to a set of related label stack entries. They need to be contiguous. So a set of label stack and contiguous label stack entries in the MPLS label stack. Then we have the indicator for this, the network action substack indicator, or NSI in short. This refers to the special label that indicates the start of the network action substack, and we sometimes refer to this as the M&A label as well. I again apologize for throwing in so many new terms at you, but don't worry, you will get a hang of these terms as I walk through the rest of the slides. Let's now get into the use cases for M&A as listed in the draft that's referenced here. This is the list of use cases that are currently specified in the M&A use cases document. And I'll walk through each of them in the next few slides. First up is no further fast readout. This is the simplest of the use cases. Mpls fast readout, as you know, is widely deployed. It's a tool that's used for minimizing packet loss in the case of a link or a node failure. There are several scenarios, however, where once fast readout has taken place, a second fast readout is not desired. In the certain cases where it's quite harmful, and the reference draft here, draft compiler, Um, I think
Yeah, Pavan, yes, we were
yeah,
on
yeah,
the wrong
yeah,
slide. So
yeah, yeah. Yeah, I'm going blind. If for some reason I can't see the slide. So, um, so we are on slide 8, right? Yeah.
we're on slide 8. Yes.
Okay. Okay. Um, yeah, I'm a bit fat finger this morning, so let me know if I skip a slide or two. So I was talking about no further fast readout. So there's this draft that's referenced here, draft compiler, which does talk about a scenario where you may end up in a routing loop if you attempt to do a second fast readout. So potential solution for this is to have an indicator in the packet to say no further fast readout is desired. The second use case that we have is in situ OAM with MPLS. In situ OAM, the operational and telemetry information gets recorded in the data packets while they traverse the LSP path. I believe there's one flavor of IOM where this ancillary data needs to be updated hop by hop, and there is another flavor where the action has to be invoked only at the edges. So an MNA solution for this would have the packets carry the IOM function indicator along with the corresponding ancillary data. So we are, do you guys see the network slicing slide now?
Yes.
I'm
Yes.
assuming it is. So the third use case discussed in the draft is related to network slicing. In the draft that is referenced here, which I'm a co-author on, we talk about this notion of using network resource partitions or NRPs for realizing network slicing, and how traffic streams belonging to one or more slices can be mapped onto a network resource partition and provide an NRP specific forwarding treatment. So what we are looking for in this scenario is for the packets of a specific slice flow aggregate to carry a marker which we call a flow aggregate selector, which can be used by nodes that are being traversed to identify and apply a specific per hop behavior that's defined for the network resource partition. The next use case is I'm on slide 10. The next use case is related to time sensitive networking. The high level idea here is to have the packets carry time budget associated with every hop, something like a local deadline to influence the scheduling of packets. Then we have the service function chaining use case. There is an existing RFC 8595, that talks about how service function chaining can be realized by emulating the network service header using MPLS label stack elements. Uh, MNA can help with extending this emulation by carrying additional NSH context in the data packets. The next use case is related to network programming. RFC 8986 talks about how SRv6 enables this notion of network programming where certain functions can be encoded in the data packets and invoked on relevant nodes. The idea with this use case is to mimic the same with MNA or for MPLS. The last use case that's discussed in this document is APN, or application aware networking. Again, in APN, the application specific information is encapsulated at the network edges and it's carried in the packets traversing the APN domain. And MNA can help with carrying this APN specific data in MPLS encapsulated packets. These were the use cases. So let's look at the requirements that are documented in this draft that's referenced here. There are 4 broad categories of requirements that are listed here. General requirements, or requirements that just enumerate good generic design principles for the overall structure and encoding. Then we have a set of requirements that are imposed on how the MNA substack indicator is defined. There are a set of requirements on how the network action indicators would need to be defined and encoded. And finally, we have a set of requirements on how the ancillary data needs to be defined and encoded. Requirement documents in IETF can sometimes err on the side of being too pedantic, but it's okay to be pedantic, especially in this case, because we are defining something here that would have a profound impact on the future of MPLS data plane architecture. Um, I'm on slide 14. This slide lists all the general requirements. I will not go through all of them, but I'll highlight a few to give you a sense of the requirements in this category. Like I said, these are just good principles to follow. You will find some of them to be quite obvious. The proponents of MPLS always prided in the fact that it's very simple. The data plane mechanism gives you that simplicity, and the use of control plane context makes it remain extensible, flexible, and efficient. So a generic requirements that it's listed here is to ensure that we maintain these properties as we add the M&A extensions. There are a couple of backwards compatibility requirements. There's one that states that new extensions must not be inconsistent with the existing architecture. There is I think, a couple of security requirements as well. There's one that states that the M&A solution must not expose confidential information to the intermediate nodes. There is a requirement here which states that the M&A solution must not increase the size of the MPLS label stack more than is necessary. But as you all know, quantifying what is more than necessary can be tricky at times. I think you get the drift of what generic requirements are all about. So I will move on to the next one. These are the requirements on how the M&A substack indicator would need to be defined. The M&A substack, if you remember from the terminology section, is the set of related contiguous label stack entries in the stack, and the substack indicator is the first entry in that substack. So it's the first entry in that substack containing a special label. And there are three simple requirements here. The M&A solution must define how a node figures out that network action indicators are encoded in the packet. And if the indicators are present, the solution must specify whether the indicators are to be in stack or post stack. And the last requirement is more of a plea to the solution developers. The plea is to not splurge on special purpose labels because they're very limited. This slide and the next are fairly loaded. Again, I'll highlight a few to get you to give you to make sure you get the drift of the respective requirements category, and you can explore the rest in leisure. This slide enumerates the requirements on the network action indicator, or NAI. And NAI is an indication in the packet that a certain network action is to be performed. A network action indicator must not be delivered to a node that is not capable of processing it in an acceptable fashion. So, and it should not show up at the top of the stack at a node that does not know what to do with it. The NAI specification must be able to say whether the scope of the action is end-to-end, or it's hop by hop, or whether it needs to be processed only on select nodes. The solution should allow indicators for multiple actions in the same packet, and should also support it should also specify how partial processing can be supported, meaning if a node cannot process all the actions that are there in the packet, it should still be able to do so. NAIs are typically inserted at the edge routers, but like I said, they may be processed at both the LSRs and LERs. The solution must specify whether ancillary data is required for the action, and whether this data is in stack and or post stack. There is also a requirement at the very end here which recommends solutions to support private network actions. Let's now quickly look at the last set of requirements. These are the requirements on ancillary data. Solutions that use in-stack ancillary data must justify why they require in-stack ancillary data, and they must be mindful of how much quantity of the stack they're using up. There must be a common preamble, if you want to call it, for the ancillary data, so that a processing node can easily determine whether to process it, or ignore it, or in some case discard it. The solution must allow an LER that is inserting the ancillary data to figure out whether a node that needs to process the data can actually read it, And for this purpose, the recommendation is to make use of existing control plane extensions. There is this RFC 9088, which talks about how you can advertise the readable label depth of each topological element. So a solution may make use of that when inserting the ancillary data. I'll stop here for this section and I'll let you go through the rest of the requirements on your own in leisure. The hope here is that you got some sense of what each of these requirement categories are. So let's look at the framework, which is specified in the document that's referenced here. Um, the objective of the framework, as you may guess, is to describe the structural and encoding considerations of the actions and the associated informational elements in an M&A solution. And we'll go over these in detail in the next few slides. By now, you should have some idea of what an M&A solution would entail. It's a set of network action substacks plus possibly some post-stack data. A network action substack contains the substack indicator, set of indicators, and any associated in-stack ancillary data. The ordering of the in-stack data label stack entries corresponds to the ordering of the network action indicators. And if there are multiple actions that are post-stack data, the ordering of their post-stack data corresponds to the ordering of the corresponding network action indicators. There's still a lot of debate around how ordering has to be dealt with. It's a hard problem to solve. So keep an eye out for these changes as they evolve. This slide talks about scopes, scopes of an action. The framework allows multiple options. Like I said, the scope of the action may be hop by hop. It could just be something that you want the ingress to process, or the scope could be a select few nodes along the path. Like I said, there is a requirement that a solution should talk about partial processing. So this is basically options for a node that does not recognize the full set of actions that are encoded in the packet. The three options listed here. In the first option, the implementation just stops processing network actions if it encounters an unrecognized action. All subsequent actions are not applied. In the second option, the packet is simply dropped if it contains any unrecognized network action. And the third option is to process the ones that the implementation recognizes and uh, ignores the unrecognized ones. The next slide, which is slide 23. This slide talks about control plane signaling extensions that can be made use of for M&A processing. I did mention 9088, which is the one that talks about advertising RLDs, the readable label depths. The M&A specific capability of nodes can also be signaled via some link state protocol, and the actions can be applied accordingly. The next structural consideration is positioning, positioning of the action substack, to be precise. Uh, um, it should never show up at the top. If a node pops a forwarding label immediately about the network's action substack, then this node, the onus is on this node to also pop the substacks that immediately follow it. It is possible for an action when processed by a node to affect state in the network. So what this means is that an action encoded in a packet may affect how subsequent packets are handled. So that's something to keep in mind when you're defining an M&A solution. We have so far looked at some of the structural considerations. That's I think the next set of slides look at what we call encoding considerations. And the first one in this list is what we do with the M&A label. The first one, so M&A label, like I said, is the first label stack entry in the action substack. There are a few choices for how this special label can be encoded in an M&A solution. It can be an existing base special purpose label. So you basically repurpose something that is about to be obsoleted. It can be a new base special purpose label. It can be a new extended special purpose label, or it can be a regular label with some user-defined semantics. Burning one or two special purpose labels is fine because you're talking about using one for a set of actions. If you are well versed with how a label stack entry is encoded, you would know that um, the label stack entry as defined in the base architecture contains a 20-bit label, a 3-bit traffic class field, a 1-bit bottom of stack indicator bit, and an 8-bit TTL field. Um, One key insight here is uh, for the M&A label, only the 20 bits of the label value and the bottom of stack bit are significant. So that leaves us with sort of 11 bits, the precisely 11 bits that a solution can repurpose if it wants to. So the two encoding options, one where the TC and TTL are retained and the other where they are repurposed or illustrated here. And going by the implementations that are out there, there's a very good chance that most solutions would just repurpose these 11 bits. This slide discusses options for encoding the length of the network action substack. This is useful, especially when an implementation does not understand the full contents of the network action substack. The two options, one option is to just have a bit to say, a bit to indicate whether the network action substack continues on to the next LSC or not. And the other option is to use an explicit length field. And the advice that we have received so far from hardware engineers, both within Juniper as well as from our friends at Broadcom and other places, is that the length field is preferable because it minimizes branching in the logic. This talks about how scopes need to be encoded. Again, you can explicitly specify what the scope needs to be, or it could be implicit based on what the actions are present, what actions are present in the packet. There are some performance implications with using implicit encoding, so it does seem like explicit is preferred. Um, this slide talks about encoding of network action. This is a topic that has received a lot of debate in the design team meetings. So this is probably the most important slide in this deck. There are two options for encoding the network actions. One option is to use bit catalogs and the other is to use operation codes. With bit catalogs, as the name suggests, the set of network actions present or encoded as a list of bits. Bit catalogs are quite efficient if the number of actions present is high and the corresponding catalog is small. So what I mean by that is, say the first 16 actions are all present, then a catalog can encode all 16 actions in 16 bits, right? The catalog approach can become inefficient if the total number of possible actions is large. So if we end up standardizing like more than about 256 actions, uh, then, and if you want to select only one action, that is the 256th action, then you would require a catalog of 256 bits, and um, that is deemed to be inefficient. But there are ways to get around it. For example, a solution may include a bit remapping mechanism so that a given domain may optimize for its commonly used actions. With opcodes, the set of actions present are encoded as a list of operation codes. Uh, each opcode is a fixed number of bits. Eight bits is what is currently being floated around. Opcodes are efficient if there are only one or two active network actions. So, for example, if you want to, if an opcode is 8 bits and you want to encode two network actions, then you use up 16 bits. However, if there are 16 actions, then you would consume 128 bits. Opcodes tend to become efficient at encoding if there are a large number of possible actions. So going back to the previous example, if there are 256 possible actions, and if say only the 256th action is to be selected, then that just requires 8 bits. The jury is still out on what design approach is better and if there is room for both. The design team is still debating what design principle is more important here. Is it packing efficiency or generality? There's no answer yet. So keep an eye out for how this debate pans out. Uh, this talks about encoding of post-stack data. Again, the key thing here is ordering. If there are multiple instances of post-stack data, they should appear in the same order as the relevant network action substacks. And within a given instance, again, the same order as the relevant functions in the NAS must be preserved. This is the last slide on the framework document. This talks about the list of things that an M&A solution should specify when defining a network action. So solution is expected to give a name for the action, talk about the indicator as encoded in the packet. It should talk about the scope of the action. It should talk about whether the action updates the state in the network or not, on whether this is a required action or an optional action. And it should also provide details on any associated ancillary data, whether in stack or post stack. Um, before I wrap things up, I would like to provide references to a set of candidate solutions. This is not an exhaustive list by any means. For post-stack ancillary data, there is a draft which seems to have garnered consensus. That's draft song. I'm listing only one here. For in-stack ancillary data, there are multiple drafts listed here. With some amount of overlap among a few. I'm part of the first draft, draft Compella, which talks about bit catalogs. And then there's draft JAGs, which talks about opcodes and the use of bits only for carrying actions that do not need ancillary data. Then there is draft dong, which where the focus is more on post-stack data. There is also another document listed at the bottom, which takes a totally different approach and relies on control plane to process network actions. It makes for an interesting read, but there are some limitations with respect to what use cases can be catered to with it. But I've listed it here, nevertheless, to give you a full picture of the solution landscape. Down to my last slide. I understand that this was a lot to process in one sitting, but I'm hoping that I've managed to pick some interest in some of you on this topic. If you want to investigate more on your own and participate in the discussion, please do visit the Mpls Open Design Team Wiki, and you will find all the details that you would need to participate and contribute. With that, I would like to take some questions, if any.
Thanks, Pawan. Thanks for a very interesting.
I can't hear you through. Sorry.
Testing.
I can now. Yeah, good.
Okay, perfect. Usually a lag before he starts speaking. Yeah, so thanks for a very good presentation. Thanks for giving all this info, very comprehensive. The links will be posted. So there were some questions on that. So once the meeting gets over, both the recordings and the links to both the presentations will be there. So you will have all the details that Pawan covered today. So let's start with the first question, which is a very interesting one. The first question is, are we making it ready for SRv6 equivalent to M&A? That is basically, are we borrowing things maybe from SRv6 and IPv6 extension header? Pawan?
There was a use case that talked about network programming. In that sense, yes, at least that part of, that piece of functionality that SRv6 advocates, being able to encode functions and invoking them on select nodes, that is being mimicked. But yeah, Mpls is a well deployed piece of technology that's out there, and anything that we can do to push the longevity is a good thing. And like I said, things have changed drastically over the past couple of decades. The base architecture came out more than 2 decades back, and now there are architectures that can do pretty much anything. So it's time that we re-architected it. And if some folks want to see it as a competition for SRv6, then so be it.
A related question would be like, there was now in the IPv6 extension header world also, there were things that people are looking at like, oh, we could have done better, or these are the known problems with IPv6 extension header? Are they things that in the working group, in the design team meetings, have come up? Like, what are the lessons learned from the past when we are designing things like this?
Absolutely. Yeah, I think we are all wise, given how SRv6 has developed. I mean, even with SRv6, we started with something that is quick to come up with, and then we started optimizing it. Those lessons are being taken into account here. Things like how whether bit efficient, I mean, whether the efficiency on the wire is more important than just putting something out there. Those are design principles that the design team keeps debating every week. But yeah, we are looking at taking, I mean, looking at the lessons that we have learned and incorporating them here.
Ramki, you asked for the mic,
Yeah.
so you should be able to speak now.
Thank you, Dhruv. Thanks, Pawan, for a very good presentation. So my question is, right, so we are making it, as you mentioned, that we are bringing up the capability of M&A. So what are the considerations we thought about for the interoperability scenarios? Because still the legacy network, right? So if you take any service provider or any kind of thing, right? So the basic networking will be still on the legacy Mpls labels. So currently in SRv6 also, right, we are finding a lot of challenges in the inter-domain routing with respect to vendor based. So we are not able to bring the exact capability of the SRv6 capability of Cisco to Juniper or whatever it may be, right? Vendor to vendor.
So there are two things, right? There's backwards compatibility as well as interoperability. Both, I mean, backwards compatibility is a requirement. So we need to have solutions that make sure that make sure that it works with devices that don't support these extensions, right? So you have to look at things like, you make sure that these Substack entries don't show up at the top of the label stack for a node to I mean, today the architecture says that if you don't understand, you drop it, and that is not necessarily what implementations have followed over the years in some cases. But there's a requirement that you have to be backwards compatible, is what I'm trying to say. And in terms of interoperability, that depends on how the framework will shape up. The goal here is to have like one solid set of recommendations, and if everybody follows those recommendations as outlined in the framework, then you will get interoperability by design.
Okay. Why I asked this question, right? I mean, so I'm sorry, I'm going a little bit deeper on this, because in SRv6, right, when we have the base seed and micro seed, right, and there was like the SRM6 also. So what happens is a different vendor with different kind of a solution. So if you have a common agreement across the vendors and come up with the best draft, right? So it will be very seamless of implementations will be there. That's what my question.
Yeah, we can always be eternally optimistic, right? So the intent definitely from all parties concerned is to come up with one solution and not have multiple solutions. And it's been positive so far, and I think the discussions are evolving in the right direction, and hopefully sooner than later we will arrive at one solution, both for in-stack and for post-stack.
In fact, there is a poll going on, if I remember correctly, where we were asking that, like, whether we prefer single solution, and
So
most support is for a single solution.
the poll has ended. The poll result basically says we don't. The answer was inconclusive. So, but then the design team is still discussing the options that are available. Like you said, yeah, I mean, there were quite a few responses that said one solution is preferred. But then there were also some responses that said one solution is preferred, but that's our solution. So that doesn't help the cause. So, but again, there are collaboration efforts happening in the background, both on list, off list, during meetings and off meetings, and it's been positive, is all that I can share at this point in time.
Thanks. So, next question. I think that question basically, if I can rephrase it, is like, what is the killer use case here? What would be the main use case which is on the top priority for everyone for using M&A?
Um, there are quite a few. I mean, for everybody, their use case is the killer use case. But yeah, I mean, we have been, at least some of us have been advocating uh, this notion of providing slice specific treatment. So network slicing service profiles where you do want to give specific forwarding treatment for specific slice flows. That we don't have a solution for that yet. I mean, there are some options, but this would be a great having something in M&A that caters to it would be I would say crucial for slicing in MPLS. And yeah, I mean, any like network programming, as the SRv6 folks have been saying, is the future. So this allows you to invoke any function. So I mean, the sky's the limit. Your imagination is will take you places, I guess.
Thanks, Pavan. I don't see any more questions. Anybody else? We have still 3-4 minutes left. If anybody wants to raise their hand, ask questions. Otherwise, thank you. Thanks, Pavan, for a very good talk, a very good description of all the details. Uh, Thank you. I would maybe start one quick poll if I'm allowed. I want to get an immediate feedback if it is possible. So I've launched one poll. You might be able to just click on the poll and you'll be able to see. You can give us feedback whether you like the topics today, whether you like the presentations today, and always feel free to reach out with suggestions. And as I was earlier mentioning, we would like to do face-to-face as well. So if your campus allows meeting like this and have a meetup, we are looking for partners. So please reach out to us and we hope to maybe have a next one face to face. With that, I would like to thank everyone. Thanks our presenters. Thanks for everyone who asked questions. All of this work is in progress. So this is the good thing is that, like, if you would like to participate in IETF, there are enough pointers as well for feedbacks. Even the feedback that you guys had today with respect to single solutions, interoperability, backward compatibility, all of this is a valid input in standard making as well. So do participate on the mailing list, and I hope to see more of you at IETF as well. With that, thanks you. Have a great weekend. Bye-bye. I would like to stop share, stop recording.